Welcome to the Dr. G Show. This is episode 183. We've been doing this for almost 6 years now. And tonight we're going to talk about a very, let's say, it's a very easy subject to talk about when you talk about it from a research standpoint, but it gets convoluted and kind of complicated once we get past that. So we're going to talk about coronavirus. This is our third time we've done a show on this. We would have done more, but I don't think I could have done it in a kind way. So, been doing lots of other topics since then, but we've had the first one when this first started, the second one, and then kind of midsummer, and then this is our third one. So, we want to talk about coronavirus. We want to talk about the hype. We want to talk about politics. We want to talk about the science, how viruses infect us, how our body actually recovers or deals with viruses. We might even touch on some natural things that really help with this. The big thing about all this is really understanding that we're not looking for a fight here. This is, I don't know if you know me, but you just let that shit go. Okay? So for people that want to kind of be a part of a conversation, that's good. But if you want to yell and scream and kind of grandiose, this is not the place for that. So I see Brianna's here. Good to see you, Brianna. Oh, she's in Arizona where it's nice and warm. If you guys don't know, I'm Dr. G. I have a practice in Kansas, of all places, where we help patients reverse acute and chronic conditions naturally, and we do it through a functional lifestyle medicine protocol, which is really just kind of knowing how the physiology works, know what people do to mess it up, teach them to stop messing it up. And it's hugely beneficial and simple that way. So I'm the one that helps reverse Crohn's and ulcerative colitis and eczema and psoriasis and asthma and allergies and all that kind of stuff, right? All those things, if it's chronic, it's something you're chronically doing. I have a DC degree and I have 4 postdoctoral diplomates, 2 in clinical nutrition, 1 in functional medicine, 1 in integrative medicine. I do research in proteogenomics. I taught anatomy and physiology for about 7 years and taught a postdoc program for about 2.5 years. So someone asked the last time, like, am I an expert? I'm not your expert. I'm going to stand on the shoulders of researchers who have kind of stood the test of time, and even quoting the CDC, and kind of go from there. But I have taught virology as part of anatomy and physiology for 7 years. I've taught microbiology. I taught additional virology through there. I taught immunology. I've taught, all kinds of postdoc education on immunology and virology and all that. So pretty well versed in all this. Hopefully I can make it all very simple for you. We can get kind of distracted with complication in life, but really things are very, very simple. So last episode, though, we talked about cholesterol and why there's the cholesterol myth and how cholesterol is your hormones and your progesterone, testosterone, it's vitamin D, so we don't want to mess with those. And we talked about the dangers of statins, and we talked about the real causes of heart disease. So go back if you didn't see that one. That's a great episode, too. And I see Gina's on here. She says, you can't piss me off. You're funny. That's my benefit. If you add a little bit of humor, people don't get pissed off, right? Maybe. All right. And, she says, the pissed off the Sedgwick County and Harvey County. I actually have a couple things that I've been to that I was a guest speaker and not reintroduced back because they did not like what I had to say. So that's why we have chocolate and vanilla. I'm not the right flavor for everyone. So what we want to do is kind of foster conversation today. So with our, let's see, the first time we did this, they were like, oh, everybody's going to die. The second time we did this show, we realized other countries and even our own posted stats that about 99.64% of people are going to survive. At this point, we have a new vaccine, and almost the minute it came out, we suddenly had all these new strains that were more virulent and may not be accounted for in the new immunization. So we want to talk a little bit about immunization versus how your immune system works, and talk about those new strains also. Um, so I'm going to kind of jump around a little bit here. We only have an hour, so I'm going to try to get through everything. But I want to talk a lot about research. Um, so first things first, what the hell is the coronavirus? So we keep calling it COVID-19. There's not 19 other or 18 other coronaviruses. That's just because in 2019 is when it was discovered, or not really, but that's when it hit the world market. So we called it 2019. So with COVID, it's just a cold virus, and some people got upset with that because they felt like it was discounting it, but it is literally a cold virus. So you have about 200 different cold viruses, which also include influenza. Influenza is a cold. It gets its own name because the pandemic in 1918, where they said Spanish flu killed a bunch of people. So it got its own delineation in there, but really flu is just a cold virus. So there's 4 different types of flu viruses, but there's 200 total cold viruses. And corona has been around for quite a while. The new novel one, so this is why it's important. Yeah, sure, we got 5 different coronaviruses out there. We've known about them, I think, since the 1950s. But this new one was unique. And so we had a pandemic about 17 years ago. I think 2003 was the last COVID coronavirus pandemic. That one thing was 10 times more lethal. And if you remember, we did nothing, and that's why you don't remember it, right? None of this happened with that. That was 10 times more lethal as a COVID virus. So you might hear this as the Wuhan virus in the beginning, or some people might call it the China virus, which is slightly racist. But COVID 2019, COVID-19, COVO 2019, SARS-CoV-2, it's got lots of different names already, right? Now, it's important to know that this virus is only important because it can go from animals to a human host. So there are thousands of different, I think there's like last count, let's see, the Journal of Science in 2020, it said that this new coronavirus was discovered in horseshoe bats and jumped into humans in 2002, right? The 2,000 novel coronaviruses are found in about 10,000 bat samples. So just in, I think it's Yunnan province of China, they found over 2,000 novel coronaviruses, right? There's only about 5 that affect humans, because for a virus to infect a human, it has to be able to bind to a specific receptor. So this new COVID is unique because it binds to the ACE receptors in the lungs. That's why you see it so problematic with things like hypertension, because the lungs help determine your blood pressure, just like the kidneys. But also you'll see it turn into secondary pneumonia, and then that's when you actually kill people. So there's out of this 2,000, there's about 500 that are SARS. So you'll hear that word a lot, SARS, S-A-R-S. That's severe acute respiratory syndrome. Basically, it's going to turn into secondary pneumonia for you. That being said, not all coronaviruses are SARS, but like we saw the pandemic in 2003, that was a SARS-CoV one. Sometimes you'll see H1N1s, but those are typically flu viruses that look at the hemagglutinin and the neuraminidase, and that's how they attach and inject into the cells. That's why those are important. So late in 2002, they started having these new cases, and this was all published, right? So the SARS that we have now was already discovered back then, and in fact, its genetic sequence of 20,000 nucleotides was published on a site called virological.org, and it was stored in Wuhan, China, which is where this all supposedly started, right? Now, other coronavirus pandemics or other kind of like animal to human pathogens, swine flu, bird flu, avian flu, those all went from an animal, jumped over to a human, because humans are pushing out into animals' territories, right? So even like the bats eat the fruit, and then they drop their viral load into the pig troughs, and then the pigs end up getting swine flu, and then people eat the pigs, and then we end up with swine flu, right? So there's all these little vectors that are play here when it comes to these kind of viral infestations for us. So with this coronavirus, it only takes about 10 nucleotides. So there's 29,000 nucleotides. And it only takes about, 10 of those to actually transfer to a human one. So the 2019 version that was called RATG13. So we knew about that 25 years ago, and then it was stored at the Wuhan Virology Institute, published that sequence online. So that is kind of where this all started from. Just a bat virus that transferred to human because it bound to a receptor that we have. Now, when we look at viral infections in general, viruses are pretty simple, and the way that your body handles this is really simple. So imagine you have a cell, and you have cells around it, and then kind of like a neighborhood, your house and then houses surrounding it. So the first thing that happens is you have to have not exposure to virus to cause an infection, but a breakdown in your barriers to get an infection. And this is where germ theory kind of fails for us. So a lot of times we're like, well, germs cause disease. But that's not true. You can go into a room of 20 people, cough on them with coronavirus, 3 might get affected, 7 may do nothing. They all got exposed, but why did those 3 end up getting infections? And that's because, like what Harvard says is, you have this huge coating bacteria. You have all these like mucus barriers, and those trap. I mean, you make 10 cups of mucus that drain from your head all the way down back to your throat into your stomach. And what that's doing is it's like a giant fly trap catching all these pathogenic viruses and bacteria, and then your stomach acid destroys and kills all those, right? So if you get coughed on all day long and you have this great little fly trap or mucus tract, then you're fine. But people are dehydrated, and then they don't have as thick mucus, or they take things to dry it up, and then you end up allowing that to get through. You should be coated. Harvard says you should have 750 to 1,000 species of bacteria that live in and on you. And literally that creates a barrier wall between you and infections. So everybody's coated with yeast. But why do some people have yeast infections? Everybody has Clostridium difficile, but not Clostridium difficile infections. Same with VRE, same with staph. Your whole body's covered with staph, but not everybody ends up with a staph infection. So it takes a break in that barrier. So as we kill off good bacteria, we don't do fermented things, that becomes a problem. We're dehydrated, we break down that barrier. We tend to eat a bunch of sugar, which changes the pH, which then changes what bacteria can live in there and on there, which then allows for bad bacterial growth or viral content to get through. So first thing is you need exposure, but really you have to have the bypass of immune barriers. Once you can bypass those barriers, you can get to the actual cells. Once you're at the cell, you have to find a cell that you can actually penetrate. So attachment to cell host is often limited based on what they can attach to. So like HIV has to attach to a GP120 surface protein molecule, and if it's not there, then it can't attach. So that's where, like the new coronavirus, it attaches at the ACE receptors. And then it has to be able to penetrate its viral load or virons through the cell membrane. So it does this through something called receptor-mediated endocytosis. So you have to have a port that you can actually send your viral load into. Because the whole purpose of a virus, viruses are weird. They're more than any other living thing on Earth. But a virus is not alive. So we talk about killing viruses, but they're not alive. They're just little genetic codes that inject into your cells so that your cells will make more of that genetic code. In fact, more cells make more genetic code, and that's it. That's his whole thing. I mean, if you're a tardigrade, then you integrate some of that viral DNA, and now you can survive in space, and you have superpowers, right? Tardigrades are the dopest creature alive. Eight-legged bears, if you never heard of them. But for the rest of us, we have to have this kind of infusion in there, and then it has to replicate inside your cell. So it changes your DNA from basically repairing your cells to making more viral load. And then when the cell decomposes, it releases all that viral load into your neighboring cells to infect them. So it's got to assemble the new viral load, and then eventually it dies and breaks open, and that's it. That's the whole purpose of a virus. Like, it's insane, right? That doesn't seem like a very normal thing to have, but there's got to be some benefit to that. Now with biometrics, so I did biomedical engineering coursework through an OC course at Yale Medical School, or Yale University. And Dr. Saltzman, they were talking about actually stripping out the viral load and putting DNA patches that we want, or even medications, then infecting people, and then it releases medication, or it creates a viral change that we want. So where you have something go in there and change your DNA, what if we could then use that in a medicinal way? And that's one of the foundations of biomedical engineering. Very interesting stuff. I remember in grad school asked my professor if we could do that, like, why don't we do this? And then now that's what we do. Like, he'd never heard about it, but it made sense. So that's how the virus has to get in. So you have all these little kind of like barriers between you and getting infected by any kind of cold virus, let alone COVID. Now, once it's in there, what happens is your body should react to that, right? So it has immunoglobulins that if you've ever got coughed on by someone with coronavirus, it has a sequence that it looks for, and it creates a database. And then creates a T memory cell and a B memory cell. And then when it gets exposed to it again, that's when your body says, hey, that's coronavirus, let's attack it. And the more and more you get exposed to coronavirus, the faster and faster your immune system gets, and then you're immune. That's how it works. That's how it works for every virus and bacteria that your immune system has ever created antibodies towards. But once it's injected, you have these regulatory cells that come through and notice that there's an infected cell. So no matter what virus it is, whether it's corona or whether it's 200 other viruses or whether it's influenza, you have cytotoxic cells, interferons, and cytotoxic cells, and natural killer cells. And the interferons will basically block all the entrances and doors, but not of just that cell, of all the cells around it. And then cytotoxic cells and natural killer cells go through and kill everything in there, right? So I always give the example. The way your body works against viruses is amazing because it can't outbreed it. So it's got to destroy the factories. And it goes overboard with this. So if you have, say, someone breaks into your house, the cops show up, they board and nail all the windows and doors shut. Then they go around to the neighbors and they nail all their windows and doors shut, and then they burn down that neighborhood. That is how your immune system gets rid of viruses. That's why it's so freaking effective with that. So really, your actual immune system is the only thing that really gets rid of viruses or bacteria, right? So one big chunk we missed is, hey, why are we not doing stuff that supports the immune system and helps get rid of, helps the body get rid of these infections? So that's a whole chunk that's completely missed in the way that we're approaching this. And a bunch of people get a lot of flack because of that, because they're wanting to do natural stuff. But what most people don't know is the medication versions of what we use were natural medicines before. So something as simple as Tamiflu, which they were all hyped up about in the beginning, Tamiflu was derived from the Chinese star of anise. So again, that thing that you put in like chicken noodle soup or in what are those, pepper nuts? That's where Tamiflu comes from, right? All drugs, all 900 pharmaceuticals that we've created have all been derived from something that naturally occurs already, and then we add something that never existed, and then we call that a medication. someone had something else, and then they called it a different medication. But so then you have 20 different people making the same thing off the original product that was there, whether it's ginger, or rosemary, or turmeric, it doesn't matter. So, a little history though about influenza, or sorry, coronavirus. So the previous coronaviruses, especially when we look at SARS, so that's the only thing that we really care about this time is SARS. But in 2003, you had the southern China SARS, infected about 3,000 people, killed about 774, and then disappeared a year later, right? So it took a whole year to basically create herd immunity, and then we had these antibodies, the T cells and the B cells now had memories. Everybody gets infected, most everybody gets antibodies, and then it's gone, it's done, right? Nobody cares anymore. Swine flu, same one. Now that's the H1N1, which is a type of flu. So anytime you see H1N1, we're always referring to a flu. That in 2009 killed 151,000, mostly in Africa and Asia. So of course Americans didn't care. About 12,000 in America, and the vaccine for it was started in 1976, but very quickly stopped because it caused Guillain-Barré syndrome, which is destroying the nerves. Then we had MERS. Now MERS is still kind of going on. So that's Middle Eastern SARS, or that one actually is a COVID, right? So that's MERS COVID. It's created about 850 deaths in about 27 different countries. But of course, we say this stuff, but no one's getting MERS tested. Nobody's getting Southern Chinese SARS tested, right? No, none at all, right? And then we have the 2019 one. So that one, again, when we start looking at the data, it's pretty consistent by all the countries. We find that you have a 99.64% survival rate. We find that, like, if you're over 70, you have a 7% chance of dying from it because of the pneumonia side effect or complication. But that means, again, over 70, you still ended up with a 93% survival rate. Over 80, you had a 14% chance of dying. But that means 86% of people are going to survive it in a population where the average lifespan is at only 78 years old. So that's pretty good. And then we found out, of course, that's pretty consistent through the research, that 86% of those that do die from COVID, just like anything, already had pretty significant comorbidities. And some of the comorbidities that they looked at, of course, for this was hypertension, because this is a lung virus, and obesity, because type 2 diabetics are 1 out of 2 Americans, and that nobody dies of obesity, nobody dies of even diabetes. We die of all these other systems that have been broken down for 16 to 30 years before they get the diagnosis. So they're saying, okay, well, if you're obese, most of those obese people are already either diabetic or pre-diabetic with a whole lot of destruction going on before they'll ever get diagnosed with that diabetes, right? So these are people that are high risk for heart attack, stroke, kidney disease, and that's, of course, what we're seeing with that. So no surprise with that. When we looked at the numbers from the World Health Organization, and this is also the clinical directors of the U.S. National Institute of Health, their final report said 78 to 85% were caused by close contact. Of course, we'll talk about touch versus droplets. The duration was about 2 weeks, which is about the same. 5% needed oxygen, and then the average duration of oxygen requirement for the 5% was 3 to 6 weeks. But we now know that people that go on the respiratory machines tend to not fare very well, but people that tend to need to be on respiratory machines probably wouldn't have fared very well anyways. Symptoms, 88% had fever, 68% has dry cough, 38% is fatigue, 33% productive cough, 18% sore throat, 14% headaches, 14% muscle aches, 11% chills, 5% nausea, vomiting, 4% diarrhea, 0% runny nose. So it's kind of interesting because, again, when we look at this, it's very vague, very, very vague symptoms with that. But they go along the same with most cold viruses because it's a cold virus, right? Your body does not necessarily react differently from one virus to another. Some people have when I did postdoctoral lectures, we'd say, is this a viral infection or bacterial infection? And how do you know the difference? By looking at the patient. And they would come out with all these kind of like, if it's yellow snot, or if it's green snot, if it's productive cough, non-productive. None of that's true. None of that's true. Your body does not have a different reaction to a respiratory viral infection, right? It isn't like, holy crap, this one's this one, so we're going to react this way. So that's why you see just vague generalization of this, right? Which is very frustrating for people, because now they're going to end up thinking that they have it based on well, I'm fatigued, or I have a sore throat, or, but most everybody during this time should. Now, when we looked at mortality rates, that's the real concern with all this. Just know, please understand this, 100% of Americans are going to be exposed to coronavirus. 100%. Every single man, woman, child eventually is going to be responding to coronavirus, right? When we saw the last corona outbreak, it lasted a year, 2003 to 2004, because 100% people get infected by it. Only a tiny fraction will be positive. Yeah, fairly tiny fraction. Let's say that fraction. Tiny amount of those are going to become severely complicated, and then a tiny fraction of those will actually die from this. So everybody gets exposed to the flu every single year. If we could end the 750,000 people that died between the last coronavirus and this coronavirus, we probably should have done that, right? Of course, we find that the vaccine was only 0 to 5% effective, because every time you get infected with the virus, it's going to cloak and change. So eventually you have enough that the old immunization doesn't work anymore. So that's why we have such a huge false positive rate, false positive when it comes to flu vaccinations. Now, what's sold and what's research-based is based on 0.00025 versus 0.0005 something, and then you're like, well, it's 97% effective. But if you round it out to the 1000th percentile, it's 0. Yeah, sorry. And even on the news, there was a report where they said, well, come to find out, the CDC said that it's only 0 to 5% effective, but you should still get the vaccine. So there we go. That's because it keeps changing all the time, which then makes antibiotics. If you look at the bacterial reactions, within 5 years you have national resistance to to an antibiotic, and within 11 years you have global resistance to that antibiotic. So we now have, of course, bacteria that's resistant to all man-made antibiotics, because that's how they survive. If you attack this way, they will change and modify. We do the same thing in warfare, right? It's a no-brainer with that. But viruses do the same thing. So these new strains that you're seeing, the 3 or 4 different new virulent strains that are, of course, in the U.S., even though they originate in other countries, that's just modification, enough modification. Now the vaccine's not going to work, right? So that's great. But that's exactly what should happen, right? Exactly what should happen. The viruses and bacteria is always trying to outsmart T cells in their memory. So if there's a wanted poster for Dr. G because I robbed the liquor store, guess what I'm not going to look like when I go to the liquor store? I'm going to shave off my beard, and they're going to be like, it's kind of like Patrick, but Patrick has a beard. All right, so now our wanted poster doesn't work. And then next time I'm going to go with different glasses, maybe wear a wig, right? That's what viruses do. That's what bacteria does to evade, constantly try to compete with our immune system. The healthier you are, the stronger your immune system is. But you really shouldn't have even that exposure from the beginning. That should be a very rare thing. But, so everybody gets exposed with this. And the statistics have been pretty similar through the whole thing. 0 to 9 is 0% risk. 10 to 39 is about 0.1% risk. 40 to 70 is 3%. 70 is 8%. 80 is 14.8%. Or again, I said 7 to 16, but all the data points are pretty much about the same. So that's just the way it is. But that's true no matter what. You may not like that, but that's what it is. Now, research gets a little frustrating. So we're going to talk about CDC, policy, research, and what most people don't know, and this is very frustrating because this is what causes a lot of arguments, is that all these policies that have been long-standing through every other epidemic and pandemic, suddenly in 2020, we changed them. The CDC changed all this stuff. The NIH changed stuff, but all the starting information was the same through every single other SARS, and then suddenly it changed. And of course, that's more political than anything. So that becomes very frustrating because we then use politics to change our practices based on research. So all these long-standing statistical importances, now we scrap and then we change the data on that. We change the verbiage on that, right? So then we have basically all these people have different policies and recommendations from state to state, from county to county, and what the hell are you going to do, right? So it just creates frustration. So, oh, hey, there's Chelsea. So, I'm trying to figure out, we got so much information. Let's see. So let's talk about data. So just know the data points that we come up with, especially in the very beginning of all this, was really messed up because we had standards by other countries already. We already knew the statistical outcomes of these things, right? But the number of tests compared to positive is a statistical importance. The number of asymptomatic compared to symptomatic is important. The availability of the actual test to have those done, the number of false positives, the number of false negatives, those are hugely important here, right? Because we are dictating policies, shutting down economies, and you would think that they would use the same practices and procedures as we did before. But of course, we found out that if you don't test as many positives, if you don't do as many tests, you don't have that many positives. So there was a big political issue in the very beginning of like, let's just not test people. Let's make it hard to get the test. And then when you looked at the number of asymptomatics compared to symptomatics, it was always just like, hey, you don't need a mask if you're asymptomatic. And then all of a sudden, that radically changed. So for the first time in history, we're just like, man, if you're asymptomatic, you have to be treated as if you're symptomatic. And then, of course, we found out the false negatives were, I think, about 10%. But the false positives, the CDC stated in several different research articles and the publishers of the PCR test that the error rates were between 35 and 80%. So the way PCR tests work is through magnification. If you enlarge the magnification enough, you'll get 100% positives. So then there's this huge false positive, which then gives you a huge bunch of false positive for your data points, right? So then when we say, okay, there's 400,000, it's important to know that 4 out of 5 COVID deaths are in prisons. So that NPR did a story on that. So then that means the general public's only 1/5. Out of that 1/5, 1/3 of those are in nursing homes, and they're the most likely to die anyways. So you have 1/3 of 1/5, which I don't know what that is. I have to do some math. Be 350. No, that's not right. Anyways, used to tutor calculus, can't do the math in my head right now. Okay, so out of that 1/3 of 1/5, there's a 50 to 80% false positive rate, or 35 to 80%. So let's say it's 50%. So then 50% of 1/3 of 1/5 is the general public. That's correct. So that'd be actual positives, which then is this tiny little fraction. So that begs the question of what the hell's going on, right? Why are we making all these policy changes? Why are we using all these tests that are not? I think even World Health Organization, again, when political things changed, I think January 1st or something like that, they said that Now a positive is not a positive because you need two tests to really say it's positive. So then 50% of actual positive tests, let's say, of 1/3, 1/5, we could say that's real. But the CDC, along with the manufacturers, also say it can be positive for any of the other 5 coronaviruses. It can be positive for influenza virus, and I think an RNA virus, which influenza is the most common virus that you're really going to get tested positive for anyways, especially during this season. So of the 50% of the 1/3 or the 1/5, are they corona or not corona? Is it COVID-19 or is it not COVID-19? So then we end up with this tiny little amount that is the most likely to actually be positive of coronavirus in the general population. So then we say, what the hell are we doing? One of the interesting things, of course, the question is always why, right? The why answer is almost always money. So, and I can't remember the actual numbers. If you guys know the numbers, post it. One of my patients did a while back. But let's say someone has a regular diagnosis. They get X reimbursement for that. Let's say it's $1,000. I think this may be $3,000 for ICU or something like that, right, a day. If that hospital says that person tested positive, but they're in there for heart disease or diabetes or anything else, that is now a $30,000 reimbursement. The hospitals have a financial incentive to make sure everybody is COVID positive with a test that has a 35 to 80% false positive. So, and just because it's positive doesn't mean they're positive for corona. But we are diagnosing all these people with corona that may not have corona because nobody's actually using a corona-specific COVID-19 test. So that creates a big quandary here because we have shut down economies. Now, personally, I would like to say that this was Wuhan, China, where it started. They already had it sequenced. We've known about it since published in the journal Nature in 2007, right? China was having a problem with Hong Kong protests that would not end. They sprayed them with blue dye. They did all these things. They punished them. They said, you're all going to jail forever. They didn't relent. But suddenly there was a global pandemic from this virus, and Hong Kong shut down. And then they created policies that you could not protest, and now there's been no protest since. So if it's that, it kind of worked out really well, which is, I'm betting, what makes the most sense here, especially given the fact that we've had COVID before. And we've had 10 times more lethal pandemics with that. So that being said, I think that's really what it is. So then there became the financial piece, became very political. But you know, the funny thing is when I was trying to figure out like what the hell's going on, because again, giving my background and kind of information in this, I was just like, well, this doesn't make any sense. And so in January, January 30th, the World Health Organization said this is a national emergency, and then by 31st, it's declared a public emergency by the Health and Human Services. But on NPR, they had the Harvard public health expert who runs the think tank for this, and they said, you know, what's going on here? We've never seen a response like this ever. And this is just a cold virus that has a mutation. So what's going on here? And the Harvard public health expert said, this is very different from the flu epidemics that we see every single year because we've never seen them shut down countries for the flu. But the the Department of Public Health, CDC, the CDC public health expert said this is the biggest fear because we haven't seen anybody close the country before. But they said the unknown, so then why did we close countries in the beginning? And they said the fear that we don't know what this virus will do is why we're shutting borders. So the fear of the unknown created hysteria, and then because we had hysteria, we justified the hysteria. So in the beginning, there was no real solid answers about this, which then was a little bit more frustrating with that. And then you had, of course, this systematic approach to this was always, and NPR did a thing on, you have a fever, dry cough, now what? You're like, what do you do, right? And they said, whether your mild or moderate symptoms mean you have a cold, the flu, or COVID-19, it doesn't change the medical advice right now. Stay at home, rest, and call your doctor if symptoms worsen. So when we had the swine flu epidemic and they were like, swine flu is going to kill everybody, the head of Wesley got on the news and said, look, if you think you have the flu, if you think you have swine flu, do not come to the hospital. Stay home, get some rest, watch Wheel of Fortune, eat some chicken noodle soup. Stop coming to the hospital. So you had the media saying we're all going to die, and so we had to get this new swine flu vaccine. But then the hospital was like, dude, stay at home, right? It's a virus. So there's this huge disconnect. And that disconnect creates a lot of arguments on Facebook, a lot of arguments even in your family. And the question is, what the hell is going on here? So, couple things. I'm going to just kind of go through some factual things here, right? And then we can kind of talk about the vaccine and all that too. So in CNN on May 26, 2020, CDC reports the antibody tests for its COVID-19 are wrong up to half of the time. So that's our 50% failure rate. And that's not for COVID. If it is positive and it's accurate for positive, so it's not false, it's still for flu, certain cold viruses, and COVID. And then on NPR on April 15, 2020, antibody tests for the coronavirus can miss the mark. No FDA standards for the COVID test. One of the scientists, Dr. H. Gilbert, says an antibody test is much more likely to be wrong in a population where there's very little COVID exposure, because again, it's testing positive for other different COVIDs and other different cold viruses. The FDA says that here's what would happen if you use the test with a 90% specificity in a population where only 1% would have the actual coronavirus. Nobody knows for sure, but that could be the situation in many parts of this country, right? So again, you're high false positive, and of the positives, you're testing positive for other viruses. In that instance, more than 90% of the positive rates would be false positives and falsely reassuring. So when we look at our metrics by which we're dictating policy and what we do and how our families are and kind of how we handle each other, the CNN and NPR and the CDC all from the very beginning said this testing is not accurate whatsoever. And then in the beginning, we'll talk a lot about masks here. Now, I want you guys to know, I'm not your doctor. If you want to wear a mask, wear a mask. If you feel like it's effective, then wear it, right? The importance is knowing the risk and the benefits and then making your own personal choices with this. And again, if you want to do it for the global community, that's great. If you want to get vaccinated, great. You want to get all the vaccines, I don't care. Get all the vaccines. If it's 0 to 5% effective and you think that 0 to 5% effective is meaningful to you and you're not worried about the side effects or whatever, then great, do it, right? That's okay. Wear a mask, don't wear a mask, wear the most complicated mask, wear a giant airbag, I don't care, right? My goal is not to tell you what to do. My goal is to provide information that's going to foster thoughts, questions, searching for more information, and then you deciding what you want to do based on all that, which may or may not be the same as me, and that's okay, right? But understand the CDC, when people quote the CDC, they are proof testing this information and disregarding all this information from the CDC. And that's the problem with all this. There has not been a continuity of information from the very beginning, which then creates all these problems. People get all excited, but they don't know the other part. So even the U.S. Surgeon General, Jerome Adams, in March 2020, said, seriously, people, stop buying masks. They are not effective in preventing general public from catching the coronavirus. The World Health Organization also raised concerns about the potential problems that could arise from wearing a mask. False sense of security would undermine other preventive measures, right? So if you're wearing a mask and you think it's protecting you, then you're more likely to disregard the 6-foot delineation there. And at worst, self-contamination by touching a contaminated mask, because again, if we were like, this is the world's deadliest virus, but let's say you had Ebola. Would you treat your friends with Ebola completely different than Corona? Oh, hell yeah. Can you just wear any old mask? No. Could you just wear any protection? No. Because that is an actual deadly bacteria. I want to read, so I'm in Kansas, so I'm going to read you the Executive Order 2052. And in there, this is about wearing masks. So it says, oh, this is the exemption. Just so you know, you can get exemptions if you have health conditions or issues like that. Okay, let me see. Where does it say? Going through the whole policy thing here. Just then I'll find it. All right. So, okay, here. So this is state of Kansas. Definition: mask or face covering. It means a covering of the nose and the mouth. Again, don't wear your mask under your nose. If you're going to wear a mask, wear your mask, right? But that's secured to the head with ties, straps, or loops over the ears, or is simply wrapped around the face. A mask or other face coverings can be made of a variety of synthetic and natural fibers, including cotton, silk, or linen. Ideally, a mask or other face covering has 2 or more layers. So, again, CDC is now saying you want at least 3 layers, but state of Kansas is like, if you got a layer, that's fine. If you got a couple more, that might be preferable. But here you go. A mask or other face covering may be factory made, sewn by hand, or improvised from household items such as scarves and bandanas and t-shirts and sweatshirts and towels, right? So you have this kind of like fuel that this is the world's deadliest virus, we're all going to die. But then the state of Kansas is like, whatever, just put it on your face, right? And we know, research-wise, that N95 masks, so your virus, the coronavirus, is 0.1 micron. Or sorry, 1 micron. 1 micron, which is, a hair is like 1,000 microns. So it's 1,000 times smaller than a hair. And we know that surgical masks are not effective at blocking smaller particles than 100 micrometers. So a surgical mask does not block a coronavirus. Coronavirus is 0.3. That's the same as a chain link fence holding back the dust in the air, right? It'll get rid of dirt clods, but not dust. But the filter efficacy, and this is from the SITRAM. See, so this is from the SITRAP UMN.edu, where they did these studies. So they found that N95 masks were 95% effective, but only at about 1 micrometer, and only at 33 to 99 liters per minute. T-shirts were about 10%, scarves 10 to 20%, cloths 10 to 30%, sweatshirts 20 to 40%, and towels 40%. And none of those had any effectiveness at less than 0.3 microns. So the N95 filter was efficacy of 95%, surgical mask at 55%, general mask 38%. So yeah, and if you look at this, like New England Journal of Medicine in 2020, It says it's clear that masks serve as a symbolic role. Masks are not only tools; they also are talisman that may help increase healthcare workers' perceived sense of safety, well-being, and trust in hospitals. Now, one of the questions people had in the very beginning was, well, what about the hospital masks? They wear those during surgery. When I did surgical rounds, I wore those. And again, in my head, I thought, oh, that's protecting. But it's not. You are breathing out viruses all over that patient during surgery. But that's not the concern. The concern is making sure that blood doesn't spurt up and get in my mouth when I'm helping with surgery. So that was very interesting with that. And so it says all those such reactions, so this is New England Journal of Medicine, it says all those such reactions may be strictly logical. We are subject to fear and anxiety, especially in times of crisis. So the expanded mask protocol. So why did we change the CDC recommendations? And it says expanded mask protocol's greatest contribution may be to reduce the transmission of anxiety. So, over and above whatever role they may play to reduce COVID-19 transmission. And then, of course, in another study from the CDC, it says cloth masks do not catch small harmful particles in smoke. So the CDC says cloth won't protect you from smoke particles. A smoke particle is 0.7 microns, maybe average about 0.5 microns. The size of a virus is 0.1 micron. So before, when we were saying it's down to 3 microns, COVID virus is 0.1 micron. N95 masks, if you don't know this, they do not prevent COVID-19 viruses from going through. So, so COVID-19 is 0.1 micron, or 1 micrometer. So cloth masks will not stop that. The smoke particles are 5 times larger than the virus. And then it says that virus-laden small aerolized particles are about less than 5 microns, right? So that's what's going to catch. But it can remain in the air for at least 3 hours and travel long distances. And what's interesting is, of course, I don't know if you've seen it, but like if I have a mask on, my ex-girlfriend did vaping, so I did a vape, I put my mask on, I blew, and everywhere, right? So you had 2 liters that comes out. And this is the thing about how the New England Journal of Medicine, the CDC, how they all basically said, yeah, these masks are not working, and they're really just to calm your anxiety and make you feel like there's a barrier there. But the average breath is about 500 milliliters, 16 breaths per minute, 60 minutes over a whole entire day that you're awake is 7,680,000 milliliters of air. Of that let's say 7.5 million milliliters of air, 100% humidity within that. Now, big particles go through and they catch, that's true, right? But we know that, of course, all the rest of it that goes through is not stopped, it's slowed down, but all the air that comes out. So if you wear a surgical mask, air is always going to go through the path of least resistance. So if you have like a plastic shell here, 100% of the air is going out here, right? If you have a mesh with maybe 2 or 3 layers, it's going to make it harder for you to push that air out. So every breath is actually going out the sides. So that whole ill-feeling, in the beginning, the CDC said I had to shave my beard, and so that mask has to have direct content like that. If you ever went snorkeling, last time I went snorkeling in the island of Phuket, off the Karen Beach, but I have a beard, and my goggles would sometimes leak because of that, right? So it's getting water in, but those masks, if they're better and better, they're like actually really good layers and they're good. If it's not fitting properly, it's just going out the side anyways, right? So of that air that's going out, of all the air, at the end of the day, It is 7.5 million microliters of air, and then where the hell that air goes is now covered in viruses. Hundreds of cold viruses, including the possibility of COVID-2. And so, of course, air pushes it out even more, or sorry, air conditioners. So then, like we saw the studies where they said you should shut off your air conditioner. Yeah, that's great. That's a great idea during the summer. We're not going to get through all this. We might have to have part 2. Yeah, we're going to have part 2. Now, touch-wise then, if we have, let's say, one person generating 7.5 million milliliters of contaminated air in a day, and you multiply that times however many people are there, then they do these studies and they say, well, look, we know the virus lives for X amount of time. What's the likelihood that you're going to get contaminated from touching everything, right? So then they came out with these recommendations and they said, all right, shut off your air conditioner, shut off all your fans, and then wear rubber gloves. And it goes through your eyes, so you should wear goggles. It goes through your ears, so then you should put earplugs in. So then it's mask, goggles, earplug, gloves. For something you're going to 99.64% survive. So again, it's this weird effing thing that is baffling for a lot of us. Like if you're a researcher, if you're a nerd like me, and boy, I walk my line. I don't say you should do anything. So then I hopefully don't get attacked too much. But holy crap, people that are quoting the CDC are being told that they are wrong. People that quote the NIH, New England Journal of Medicine. This is not quackery. This is not some crazy false news or false flag crazy stuff, right? But it is absolutely not political. But because it became political, it became the divide. That, well, if you quote the CDC during this time, but you don't quote the CDC right after this, then you're wrong and you hate America and you're killing people, right? So let's look at surface data. And again, this surface data is from the CDC. All right. Computer mouses. So they basically did the PCR test for polymerase chain reaction for COVID. And they found genetic material at the rate of 75% on computer mice. So that's awesome. Trash cans were only 60%. Sick bed handrails, I thought that'd be higher, but it was only 42%. Doorknobs, which I thought would be just laden with all kinds of virus, only 8%. But 81% of miscellaneous personal items were positive. Exercise equipment, do not close my gym back down. Medical equipment, so the spirometer, the pulse ox, the nasal cannulas, those, of course, were just reeking of COVID. PCs, iPads, of course, all the stuff you touch because you're breathing out all this virus and it's coating everything. Remote controls, cellular phones, 83% of cellular phones were testing positive for viral RNA. Toilets, 81%. Room surfaces, 80%. So pretty much 80% of all the stuff in your room, and every room, everywhere you go, is covered in freaking virus. It's that way all the time. Just so you know. Before the mask, after the mask, 100% of that humidity in your breath is now going everywhere and is landing on everything, or it's creating a giant petri dish on your face that you breathe in and then get pneumonia. Window ledges, 81. Plastic. Okay, so this is the longevity then. On plastic surfaces, according to CDC, coronavirus can last 2 to 3 days. So that means I breathe in this room all day long. And it is coated all around this room, probably 3 feet around. It's all coated in just non-stop 7.5 million milliliters of residue from my breath. But it can last 2 or 3 days. And that's me in this room, not every single patient that comes in here breathing their hours worth. So over a whole day, we're talking about, say, 3 or 4 people or half a dozen people. you might end up having 100 million milliliters of contamination. So 2 to 3 days on plastic. Stainless steel was 2 to 3 days. Plastic, stainless steel, that's everything now. On cardboard, it was only a day. Here's the tip. Make everything out of cardboard, right? Copper, I don't know why they're testing that, was 4 hours. And that's because copper is a natural antibiotic and antiviral anyways. So 4 hours, that's pretty good. So again, this research was on the CDC. Handkerchiefs, 2%. If they were 4 layers or more, 13%. The conclusion was the conclusion from the CDC, wearing masks will not reduce SARS-CoV-2. Not reduce it. Not reduce it. Not reduce it all. Hey, and Julie Brayfield, thank you. Adrian and Matthew, good to see you guys. I hope you guys like this information. We'll probably have to do COVID Part 2 next week because we still have a ton of information and we've already went an hour here. But if you guys haven't watched this, please share it and you can save it, and it's on there and you can watch it again later too. But the CDC concluded that wearing a mask will not reduce SARS-CoV-2. N95 masks protect healthcare workers, but are not recommended to source control transmission, right? So it's great. It's like the best barrier we can have. But again, it goes down to, what do we say, 0.3 microns, but the virus is, like COVID, is 0.1 micron. Surgical masks are better than cloth, but not very efficient at preventing emission from infected patients. So, surgical is better, but it's not efficient. Cloth masks will be ineffective at preventing SARS-CoV transmission, whether worn on the surface control or as personal protective. But yet, in the state of Kansas, like many states, they don't care. The world's deadliest virus, just wear anything. Look at me. I'm now protecting the world, right? But am I? According to CDC, no. According to the World Health Organization, no. But because they changed what they were saying from the beginning of all of this, now people have a different opinion. So, next week, let's talk more about mask and barrier control. I'm pretty surprised I didn't get any hate comments so far, so that's pretty good. And then let's talk about viral load and transmission. Let's talk about the vaccine, and then let's talk about the more virulent strains that are coming out. Now, the interesting thing, just in synopsis, since you guys probably want to know about the vaccine, honestly, I do lots of vaccine kind of like letters for patients and stuff, and talk about the vaccine. The pink book from the CDC, or the FDA, FDA produces a pink book, which is every vaccine, every ingredient in there, right? Now, VAERS, they will tell you all the people that are dying and getting sick, and why there's, I don't think, $14 trillion they paid out, because you cannot sue vaccine companies if they kill you. So when Gardasil girls die, tough luck, right? So taxpayers created this fund, and then that helps offset that cost. But out of all the vaccines I've ever researched, I gotta say that this one is the least possible toxic vaccine ever. And it's because they stored it in negative 80 degrees. Now, give them time, they'll create a shelf-stable one, and that'll be full of mercury and all kinds of horrible stuff. But this vaccine is only has one real bad ingredient, and that is antifreeze. But they almost all have antifreeze in there. The sorbate that's in the other one, so there's two different major ones that we're doing here in the U.S. One has just PEG, which is polyethylene glycol, which is antifreeze. The other one has sorbitol, but sorbitol is made from polyethylene glycol, which is antifreeze. So other than that, the ingredients really did not look bad at all. But again, the efficacy is 95% for non-severe reactions, but the statistics worldwide and in the U.S. since the beginning of this is 99.64% efficacy of doing nothing, that you won't get severe complications. It's the 86% of the 14% that are over 70 years old that we're seeing the highest complications with. Now, that's not saying that we're overdiagnosing this at all from a high false positive test that's not specific for COVID-2. That's beside the point. I'll also figure out those numbers, the compensation numbers based on if they have a COVID diagnosis, how much more they are getting paid for that, because that is sketchy. So, you know, if people want to get the vaccine, get the vaccine. If you don't want to get the vaccine, don't get the vaccine. Theoretically, it's statistically better not to get the vaccine. But if you're in that age group, in that premorbidity, or you have those comorbidities, then maybe it is prudent for you to get that, right? Because this many people are going to be fine, but out of this many, what if those people take it and then they have a better outcome? Well, that's probably better overall, right? So again, I'm not anti-vaccine. I'm pro-knowledge and pro statistically what makes more sense for us, right? Off real data, not the stuff we screw up and tell people. So that's the thing too, is when you got the drug companies saying, or the CDC saying that the flu vaccine is like 95% effective, but then you also have research from the flu vaccine that says it's not, it's 0% effective. What the hell's the difference? When you see that the CDC or the American Cancer Association says that chemotherapeutics are 5% effective at best, but yet the manufacturers are saying it's 90% effective, why is there a big difference with that? And that's all manipulation of those numbers, right? So that's where you have the 0.00056 and the 0.00, but if you round it up to the thousands, it's still zero. It's still zero. But if you go all the way out to the 10,000, now we can say it's 95% effective. So they're messing with us, which I don't like. So, all right. Hey, and there's Tim. Thank you guys for watching. I guess our hour's up. Next week we'll do a second part of this COVID talk. And so think about some questions during this time. Feel free to post stuff if you want. I'm surprised nobody started an argument, so that's pretty good. Like, we did good. We didn't have one argument yet, so that's awesome. I really appreciate you guys being on here. Next week we'll code a little bit more research. I'll try to maybe put some of that research up for you guys so you guys can look at it and have access to it, because I know it's very frustrating. It's frustrating for me because I have children, and you have one parent that's saying one thing and the other parent saying another, and everybody just wants everybody to be healthy and safe, but there's this huge disparity between the same sources of information. So, all right, guys. Thank you for joining. Appreciate it. Love you guys. Have a good night. It's definitely martini time. If you end this live video, you will be able to choose